You gotta know a day. Today we're going to talk about friction again, but we're going to talk about more obscure trivia. For instance, molybdenum disulfide is used as a lubricant. In fact, when it's dry, it has the lowest coefficient of friction of any material that is known for dry materials. Now, if we're talking wet materials, liquids that we can put between surfaces, they follow something called this Stribec curve, where if you have boundary friction, you've got a little bit in there at a low speed, you're going to have the highest amount of coefficient of friction. But if you go fast enough, it's going to really, really lower that friction between the material until you hit a certain point where you hit something called hydrodynamic friction, where if you're going fast enough, that friction is going to pick up again. So the faster you go, the lower the coefficient of friction. Basically, the lower that, the more slippery it is until it hits a certain speed, and then you hit that hydrodynamic effect, and it gets faster again. It's not linear. This is called the Stribec curve. There's also a Coulombs Law of friction. Now, Coulomb is most famous for his laws with electrostatics, but there is a Coulombs Law of friction, which is kind of like the law that we talked about before, where it's essentially the more pressure you push down on an object, the more friction you're going to get. It's because you're pushing those solids closer and closer together, like this fellow here. He pushes down with more friction than some of these smaller people. He pushes down with more pressure than some of these smaller people because of his gravity. So he's going to endure more friction on even a slip and slide than the other people in the shot. And it's kind of a version of the friction equation we talked about before. The more pressure you have, the more normal force you're going to get pushing up. So that's the currently accepted version. More friction from more normal force. And usually that can come from more pressure. And then there's someone called Guillaume Amans Law. This is going to be a really early clue. He had laws for friction. He actually even looked into experiments that Leonardo da Vinci did. Specifically, the second law, the force of friction is independent of the apparent area of contact. And that's a little bit counterintuitive. But more surface contact area, like this object, does not matter which side you put it on, you're going to have the same friction. It ends up being because you have more pressure on one point, so you have more normal force on one point. But on the whole, it does not matter. It is independent of surface area is friction. He used this setup here, looked at normal force, friction on a surface, how much would keep it static. And again, force of friction is proportional to the applied load. That's, just like we talked about before with Coulomb's law of attraction. And normal force. And kinetic friction is independent of sliding velocity. That's what we didn't talk about too much. Different Coulomb's law. But, Guillaume Amans